Okay, so this question deals with isolating variables. I haven't written the entire question out, but I'll just tell you out loud what it says. This formula represents how much power is generated by a wind turbine. You guys know what those wind turbines are? They spin around. They collect energy. Okay. The P is the power generated in watts. That's going to be important because we're probably going to have to make a conversion in this question. R is the radius of the wind turbine, and S is the speed of the wind. In this question, they want us to figure out what the wind speed, okay, so we're solving for S, so S is equal to our unknown, what the wind speed needs to be when we have a radius of 24 meters. I think radius R is in meters. Yeah. And our power is 500 kilowatts. So the first things first is we're going to have to convert in this question. Okay? We know that 1 kilowatt is equal to 1,000 watts. And since power is generated in watts, we have to convert this to watts. To get from 1 to 1,000, what operation can we use? Multiplication. What do we multiply by? 1,000. We multiply by 1,000. So in order to turn 500 kilowatts into just watts, we have to multiply by 1,000. So how many watts do we need to generate here? 500,000 watts. Okay. So, in other words, in our question again, we rewrite it. I think it was r squared s cubed. Yep. Squared s cubed over 2. 500,000 is going to be our P in this example. All right? That's the amount of power we need to generate. So we'll be plugging that in for P. The radius of our wind turbine is 24, so we'll be plugging that in for R. And what we need to do in this question is solve for our S. Okay? Again, there's two ways we can do this. We can rearrange the whole formula and set it equal to S to start. Or we can plug things in and then as we go, rearrange for S. I'm going to plug things in. I personally find that a faster way to do things. That way I'm working with numbers instead of letters. A lot of times that's easier to see our next step. So, power becomes 500,000 is equal to our radius, which is 24 squared. Our S is still cubed, divided by 2. Okay, so remember the goal we said here was to isolate for S, and we have all of these values. I'm going to bring 2 over to start. Because 2 is divided by on this side, when I move it over, it needs to be, that's right. So what's 2 times 500,000? That's right, 1 million. So we have 1 million is equal to, we'll still have to square 24. S cubed. Okay, now this says 24 squared times S cubed. I'm going to figure out what 24 squared is. Maybe someone with a calculator have one here. 24 squared, 576. Perfect. So we have 576 multiplied by S cubed is equal to 1 million. In order to get S by itself, how do I move that 576? That's right. We're going to have to divide it. Since it's multiplied on this side, to bring it over, we'll have to divide. So I'm going to write it like a fraction. 1 million divided by 576 is equal to S cubed. Let's figure out what that value is. Yeah, okay, I'm going to bring it up on here. 1 million divided by 576 gives us 1,736.1. Okay. 1,736.1 is equal to S cubed. Now, who recalls how to move an exponent, Brendan?
Square root.
Okay. Now, is it a square root, or is it different because this number is a 3? Anyone know what this is called? That's right. It's called cubed root, right? So we could always say the root of 3. If we're unsure what the actual term is, root of 3, root of 4, depending on what the exponent is. Okay, so when we bring this over, we got to root it. So this becomes the cubed root of 1,736.1 is equal to S, so the wind speed. So the wind speed, in order to generate 500 kilowatts, I have to bring it in here, cubed root. So on our calculators, everyone's going to have something different. I'm going to see, do I have a cubed root? No, so I think this would be my button here. Should be this guy to the root of 3. So, let's see. This is how we can check this. We'll put this to the power of 3. So to the power of 3, that's the right button. So for me, I put my number in first, then I hit this y root of x. Everyone's calculator is going to be different, so you're going to have to try yours out. Okay? The one I have here is a little different. So 12.01. 12.01. So the wind speed, I think it's measured in kilometers an hour. Let me just check the question quickly. Oh, no, it's in meters per second. Oh, much faster. Okay, so it needs to be 12 meters per second in order to generate that kind of wattage.